Hey, this video is talking about analyzing and solving linear equations. We're going to focus on one solution, no solution, and infinite solutions. All right, so algebraic expressions can have a single solution or no solution or an infinite number of solutions. In all the work we've done so far, we've only been working with equations that have single solutions. So we're going to practice looking for patterns and strategies for these other options. So take a look at this equation. I'm going to solve it, and I'm going to start with subtracting 5x from both sides. So I'm left with negative 2x plus 7. This cancels out. 2 times 3 minus x plus 1. Then I'm going to distribute the 2 on the right side. So I have negative 2x plus 7 equals 2 times 3 is 6, and then 2 times negative 1x is negative 2x plus 1. I'm going to combine these like terms. So I have negative 2x plus 7 equals 7 minus 2x. Then I'm going to add 2x on both sides to get rid of those. That cancels out, and that cancels out. And then I'm left with 7 equals 7. And we're going to stop there. This is one way to solve this equation. I'm going to take another approach for the same equation. Right. So we're going to start with 3x plus 7 on the left, and on the right side I'm going to distribute the 2. So 5x is here, plus 2 times 3 is 6, minus 2x plus 1. Then I'm going to combine these like terms, the 6 and the 1. So I have 3x plus 7 equals 5x minus 2x plus 7. Then I'm going to subtract 7 from both sides, and this cancels out, this cancels out. I'm left with 3x on the left side equals 5x minus 2x. And I'm going to combine these because they're like terms, and I have 3x equals 3x. I'm going to divide both sides by 3, and I'm left with x equals x. Now, the problem before, we ended up with 7 equals 7. And the second strategy, I end up with x equals x. So I had 7 equals 7, and x equals x. These were my final equations in both solutions. And when I'm reading this, I want to figure out which equations are always true, sometimes true, or never true. So reading this equation here, I read this as 7 is equal to 7, or 7 is 7. That equation is always true. Let's look at this equation here. X is the same thing as x. This equation is also always true. So the solution for this equation, there's an infinite number of solutions. Let's try another example. So we have 3 times x minus 5 plus 11 equals x plus 2 times x plus 5. So I'm going to start here, and I'm going to distribute this out. So 3x minus 15 plus 11 equals x plus, and I'm going to distribute this as well, 2x plus 10. These are like terms, so I'm going to combine them. 3x minus 4 equals, and I'm going to combine these because these are like terms, 3x plus 10. I'm going to subtract my 3x from both sides, and these cancel out, and I'm left with this. Negative 4 is the same as 10. And this is my final equation in this strategy. Negative 4 equals 10. I'm going to solve it another way. We're going to distribute this side first. So we have 3x minus 15 plus 11 equals x plus, and I'm going to distribute here again, 2x plus 10. Okay. So this time, I'm going to combine these. 3x minus 4 equals 3x plus 10. And at this step, I'm going to add 4 to both sides. So this cancels out. So I'm left with 3x equals 3x plus 14. And now I'm going to subtract 3x from both sides. And I'm left with 0 equals 14. That is my final equation in this strategy. So I'm going to bring this one back. Negative 4 equals 10. And the other one was 0 equals 14. So these are my final equations solving the same equation. And I need to check, are these equations always true, sometimes true, or never true? So negative 4 is the same as 10. Is that always, sometimes, or never true? That is never true. 0 is the same as 14. That is never true. So in this equation, there is no solution.